Hello and welcome to CG Visuals. My name's Zach, and today we're going to go through step by step how to create the Expelliarmus effect from Trapcode Magic. This is the effect that we'll be creating in After Effects. As you can see, it's a very complex, interesting simulation that we're going to understand how to create from scratch. So we'll be using Trapcode Particular version 4.1.5 for this demonstration. So in After Effects, we'll start by creating a new composition, 1080p, set the frame rate and duration that you want. And then we'll start by creating a new null object. And I like to make this green and give this a name like locator. So this is going to be where our particles spawn from. So we'll make this a 3D layer. And to help us refine the look of the simulation, we want to set up a placeholder animation that will let us see what things look like when they're in motion. So to that effect, we'll have an interesting perspective going on here with the spell coming towards the camera, so we'll get a good look at the simulation and the particles. So once that's done, we've got our null object. Now we're going to create a new layer to use as our particles. So I'm going to name this Particles Projectile, as we'll have a few of these layers as we go. And then from the Effects tab, we'll add Trapcode Particular, and then you'll see the familiar sight of the particles there. And we want these particles to spawn from the locator, so we simply Alt-left click on the position in Particular and pick whip that to the position of the locator. And now our particles will follow the object there. And if we change the emitter behavior to from speed, we'll have more particles based on how fast the object travels. And instead of using a point for the emitter type, we're going to choose an OBJ model. As we'll be using fluids, this will allow us to have a volume shape that allows for more interesting fluid patterns. And even though I want the emitter size to be quite small, I'm going to keep it at 50, as that's just enough space to allow the fluids to behave. And we'll put the direction type to outwards. And then in the OBJ emitter section, we'll just change that to a volume. So now we have our volume particles emitting from a sphere. So moving forward, we'll go to the Particles tab, and we're going to use a cloudlet particle. That will give us some more interesting shapes. We'll randomize the life, and we're going to have quite a short trail of only 1.5. We can play with the feathering as well. We'll reduce the size to 3, have a bit of size randomness. I've gone for 25 there. And this is where it gets interesting, because we're going to start with a size over life linear ramp, and then we're going to create our own custom behavior for the size. And so the idea here is we're trying to go for a fizzy kind of sparkler type of vibe. So we're going to have the size constantly be changing shape throughout the duration. Once we've done that, we can go to the color over life. And we're going to choose some quite pale looking colors, because we can always define this with, adjustment layers and color correction. But I had the idea for a kind of orangey yellow type of spell. So I'm going for quite pale yellowy orange colors here. Genuinely the second color will be slightly darker, just so we get that kind of the brightness towards the beginning. And also we'll use the screen blending mode as well. So now we move to the Physics tab. So by default we're using air, and we have 3 options there, and we're going to use fluids. So by default we can see the fluids not doing much. And to get them to sort of behave in a more dramatic, turbulent manner, we're going to increase the force region size and also add a little bit of buoyancy. And then the random swirl here, that's like the amount of turbulence, and the swirl scale is kind of the complexity. So as you increase that to 500, that takes a little bit longer to calculate, but it's giving us more defined, smaller details in the fluids. And of course you can randomize the fluid seed as well. So as we scrub through here, we can see it's we're getting the pattern that we want, but the whole thing is just a little bit too slow. To make fluids look more interesting, you can always change the density field there to something like brightness. Now, in the global fluid controls, we can increase the fidelity to 6 and also the fluid time factor to 3. And that will essentially triple the speed that everything behaves at. As you increase that, you'll probably want to increase the viscosity as well. So now our trail is shorter, the fluids are behaving more rapidly, and it's just genuinely a more chaotic looking effect. And we can enhance this now by enabling auxiliary particles, and we want the auxiliary particles to stop emitting at 50% of the lifespan there. We want these to be quite small, random particles here with a screen blending mode. This time it's just going to be a sphere with a random lifespan of 100. We're also putting in 15 and 25 here for the velocity and velocity from motion, and to randomize those values throughout, we're simply adding a wiggle expression of 10 by 10. So the velocity is going to change quite rapidly, and also the velocity from motion as well. So this is just going to add some more randomness throughout the duration of the spell. We can increase the particles per second there to 100. And we're also just going to borrow that custom color curve graph that we made and put that in the overlife color of the auxiliary particles. And of course you could deviate here and start trying to create different looks. And the nice thing is these auxiliary particles will inherit the velocity from the fluids. So that'll make them behave in a more dynamic way. Obviously we want the opacity there to be 100, and we can even give them their own turbulence, and that turbulence is based off of the air physics model, not the fluids. So we have kind of two physics models working together there. Not to forget about the size over life for these emitting particles here. This time, because they're a lot shorter, we want them to start off large, start to shrink down, and then pop just before they disappear. So each one of these changes is quite subtle, but they're all slowly contributing towards that overall look. If we want to just isolate the auxiliary particles there, we can set the main particles to 0 and just concentrate on what those aux particles are doing, and then of course reset that once we're ready to continue. And then finally, in the rendering tab, I've left this till last as the motion blur is usually the most expensive here, so we'll want to enable motion blur, and we can also reduce the length of the shutter angle as well. So once we're happy with the motion blur settings, we'll have a quick look. Rather than doing a pre-render, I just like to jump through in little increments here, and I can kind of get an idea of what's happening. Sometimes if you want to get a faster approximation of the particles, you can just uniformly reduce the particle count in the rendering tab, although lower values seem to reduce the lifespan as well, so depending on how well that goes, you can reduce that value a bit. And that's sort of like making your own proxy simulation as you go. For the tutorial, I think it would be wise to keep the samples at 16, as I'm not seeing too much of a difference from this perspective. And now we can actually add some post-processing to these particles, because although they're looking good, we want to add this refine soft matte edges effect. We're not going to use any of the decontamination. What we're going to use this effect for is its chatter reduction, and mainly this shift edges, kind of like choking a matte, but it's doing it in a slightly softer way. And you can see it's forcing the opacity there to be to kind of choke the parts of the projectile that have a kind of thicker mass of particles, and then everything else is much more thin, so it's creating that interesting look. And now we can just duplicate that particles layer and rename it to Sparks Projectile, and 90% of the work is done for us. We're just going to modify a few settings in this layer to turn it into sparks. And the first thing we're going to do is just disable the main system by setting the velocity to 0, as we're only going to be working with the auxiliary particles. And rather than creating this powdered sort of effect, we're going to go for some more defined kind of sparks, more traditionally what you'd expect sparks to look like. So we're putting the emission probability to 5%. Things like the velocity, we want that to be 0, so we get those defined trails there. We also want to increase the velocity from motion, so the sparks inherit more of that velocity. And we'll also set the life randomness to 0 as well. And as for the size over life, we don't need them to be popping at the end of existence like that, so we're just going to choose the default linear size over life there. And maybe make a few other small adjustments. One thing to note is the turbulence will also affect the motion blur, so that's why we're keeping that value quite low. So each time we make a new layer here, it's good to just review the layer in the effect in an isolated setting, so we can just really judge what's happening. And when we combine them together, although it's not immediately obvious, when things are in motion and you can see the extra sparks coming off of the effect there, definitely will contribute and be more obvious later. So now that's the projectile part of the effect. One thing to note actually before we continue is that you can actually change the turbulence of the sparks by changing the fluids temporarily back to air, and that will give you access to the turbulent options here, for example increasing the complexity and then changing it back to fluids, as it's only the auxiliary particles that get affected by those turbulent settings while the main system is using fluids. So I think we wanted those sparks to sort of be moving around quite a bit more rapidly, and to just test that theory, we're going to do a controlled pre-render here, and so we should see each spark is wiggling around at a much more faster pace. I think that's definitely an improvement. So we also want to create this emission ring, which is what really sells the effect. And for this, we're going to create a new null object, and this time name it ring locator. It's going to be a 3D object as before, and we're just going to borrow the beginning keyframe for the position, as this time it's going to be a static locator. And we want to get a closer look at what's going to happen. So we can actually create a camera into our scene. And because we're just looking at a black background, we're actually going to create a reference point. So this is just a solid 3D layer, and we're applying a grid to that layer. And then if we just rotate this by 90 degrees and place that where our floor plane should be, that will just give us a kind of waypoint to understand where exactly our camera is. So using the camera controls now, we can just zoom in to that beginning point. And this spell is inspired by the spell that Professor Snape casts in the film. So I'm actually trying to get the same kind of perspective, that kind of close-up shot that you see, since we're trying to replicate that effect. And now to create this ring, we're just going to duplicate the particle's projectile layer, rename that to ring. And although most of the settings will be able to keep the same, we're actually going to Alt left click on the position and re-pick whip that to the locator. And then because we don't have any particles from speed, we're going to change the emission type to continuous. So that should give us some basic particles. Based on the settings, they're just kind of popping into existence and just fizzing around. So it's quite an interesting simulation working there. But we're going to enhance this by coming into the OBJ settings. And in order to create this expanding shockwave effect, which is a very common effect that you see in magic assets, we're going to choose this tube short OBJ layer here. And that will change the sphere into a ring. And the two values that we're going to keyframe in just a moment is going to be the particles per second and the emitter size. So I'm just getting to the beginning of the timeline where I want the ring to start from. And we're going to have a much larger value, starting at 5,000 for the emission. The size will start at 50, because it's going to be quite a small effect coming out of the wand, but then we want it to quickly expand into that classic kind of shockwave that you always see. So we'll increase that emission size to 500. As the ring increases, the particles per second will increase to 20,000. Quite a high value, but they'll only be that high for a moment before pittering off into 0. And by right-clicking on that keyframe there, we can choose a soft, easy transition, so that it increases in size and then slowly decreases as it reaches its full radius. Now at the moment this ring is facing forward, but our spell is kind of casting to the right a little bit. So if we change this Y rotation value, we can see that our ring is actually going to be rotating. If we keep rotating it, we'll end up getting to a 90 degrees kind of angle there. But 30 degrees should be, facing slightly off to the right, to our screen right. So at the moment it's looking kind of like a disc. So to help this, we'll inject more velocity into the solve. So now the particles will have to resolve that increased kinetic force, and it'll force them to kind of go outwards a little bit. So that's one step in the right direction. Next thing in the particles tab, we'll reduce the life to 1, as we don't need these to be on screen for quite as long. For the size over life, we're going to create a slightly different version here. We don't actually want the particles to be visible from frame 0. what we want is for the fluids to work in the background, and then eventually after, say, 20% of the lifespan, that's when we'll actually start to see the particles. So they're coming in at a delay, quickly expanding to their maximum size before disappearing with a linear sort of line there. So hopefully that describes what's happening visually. If you're making changes to those graphs and it's not updating, that's why you can change the random seed there. It'll force the frames to recache. And the way we get this to look like a shockwave is through some experimentation. I discovered that reducing the simulation fidelity to 4, increasing the resistance viscosity to 50, that would create more of the effect that we wanted. And then finally we go into the auxiliary particles, reduce the emission probability to 20, we'll delay the time that the particles spawn until 25% of the lifespan, but they'll continue increasing to 100%. We'll simply get rid of one of those expressions for the velocity there. And this is that powdery stuff that comes off the main ring. So we're doing starting off with a linear size here for the graph, and then we're just doing the same thing where they simply just have that little popping expression at the end there with the size. And then just checking all those settings. Make sure that their particle amount is definitely at 100 before we continue. Quite easy to forget about that. So that was quite a lot of settings we just changed. They were based off of a lot of experimentation, but now when we go through, we'll see that we're definitely getting that defined kind of shockwave that we wanted to get. So that's looking pretty decent. The only issue is that it still just looks like a bunch of particles. There isn't a lot of subtlety to it, and that's why we want to bring back in our post-processing effects here. So the current settings aren't working quite as well as they did for the projectile. So we're going to make a few changes to this refined soft matte here. So rather than having the shift edges at -50, we're going to instead use the contrast and put that to 25. Kind of like sharpness for the opacity, and the chatter reduction type will be smoother, 50, and we'll even add in some edge motion blur. So now we've taken our particle simulation, we've made it looking very soft, perhaps a little bit too soft, which is why we're going to actually compensate for that softness by adding in quite a powerful sharpness effect of 100. So that's now creating contrast in quite an interesting way. And we can even improve this slightly by adding in a CC vector blur. And to just demonstrate how this is working, we'll go through step by step here. We have sharpness, that makes things look very exaggerated. The vector blur has this kind of pinching effect. And then the refine edges there just kind of smooths everything out, and you can see we've kind of taken it from a particle simulation to something that looks a bit more natural, kind of more difficult to define. And the final step that we're going to do here is now introduce sparks to this. So by simply duplicating the particles ring, renaming that to sparks, getting rid of those effects. And we don't have to do much work because we already did all those settings to the fluids. All we're going to do is disable the main particles by setting the opacity to 0. So that will just give us the ox particles, and we're really just replicating the steps we did to create those sparks. So to have less of them, we'll put the emission probability to 5. The particle velocity needs to be at 0 to change the powder into little lines. And at the moment they're kind of they're kind of like little trails. We want them to have a lot more power behind them, so by increasing that to 50, that'll make those sparks actually push out a bit more. And we want the sparks to simply, turn off once they're done, so that's why the randomness is 0. Again, we'll just use that preset linear size there so that they just slowly decrease, slowly shrink. We'll just have a quick look at this. And remember, we have that turbulent position here for the auxiliary particles. And what we're actually going to do is switch back to air so that we can actually modify those settings, because they'll be grayed out otherwise. We're going to put the scale to 25 and the evolution to 100. So smaller movements and they'll be happening much more faster. I'll also just do that same change for the sparks projectile layer as well. Once we're done, then switch both of them back to fluids. So they inherit the velocity from the fluids, but then they're influenced by their own turbulence field, and that's what is creating these really dynamic movements. So we go through there, we're getting quite a nice result from those sparks there. And if it was just the sparks, it would kind of look a little bit like a firework, but in a moment you'll see what it looks like when it's combined together. I think one last improvement we could do to the sparks would just be to have a little bit of sharpness. Because we're using contrast, we've got one layer that's very soft and undefined, and then another layer, the sparks, that are very sharp and contrasty. And it's when you bring both of these layers together that you start to go past the, it no longer looks like a fluid simulation. It actually starts to look like some kind of pyrotechnic effect that could actually exist. And so, things don't need to be super complicated to get to this stage. We're just using Trapcode Particular. But now, because we've made all these considerations of how these particles are going to behave, we can now get the camera in really close to this effect. And it's going to look very realistic, the animation, and also, your eye is going to catch those little glimmers of the sparks. And all of the effects that we've added is what is contributing to this effect. Now we do want to give this a preview render and make sure everything looks correct. I'm just going to go back to the oh yes, one thing we actually do need to do, one extra step that we can do to improve everything, is by adding the light rays, because we have these particles, but in the films you always see that the magical spells have a lot of light coming off of them. So we're going to create this adjustment layer, call it light rays, and the first effect that we can put on here, which just affects the whole screen, is a directional centered blur of 25 with 2 revolutions with a softness of 50. And then we'll place our light ray effect, setting that to brightness. And at the moment, the only problem we have is that this 2D light ray effect isn't following the magical trail. And we'll solve that in a moment. The first thing we can do is set the adjustment layer as a 3D layer and pick whip the position to our locator. So now our adjustment layer will actually follow the spell as it moves around. And the only reason we did that is so we can actually put a mask onto the effect. So that technique is what allows us to have an actual roto mask that follows the spell. And those adjustments only look good when they're, when they're only affecting one specific part of the effect. You can see it's giving the projectile that extra sort of punch of brightness. And then the next thing we want to solve is getting the light rays to actually track with our spell, because they only look good if they're in the correct position. So to do this, we're going to Alt left click on the center and then pick whip that to the position. And I'm actually going to use an expression here that I learned from Andrew Kramer, so I'm not going to take credit for this expression. But what we're going to do here is we're going to keep the beginning part of this expression here, and then we're going to delete everything that comes after the dot, after locator there. So we'll get rid of that, and then we'll type in 2comp open curve brackets, open straight brackets, 0, 0, 0, close brackets. So we're using the straight brackets and the curve brackets there, so you can pause the video if you need to get a better look. And that's a clever expression that will somehow get that 2D value to actually track with our spell in 3D space, and the that'll work, you know, with the camera as well. Even if we move the camera around, that'll all work. And it's also going to affect the ring emission there as well. And what I noticed in the film is that the ring actually starts to form on screen first, and once the ring has kind of reached a certain point, then the spell actually comes out at a little bit of a delay. So all we need to do in order to achieve that is simply just offset those position keyframes a little bit. And so there, our ring is going to be affected by our, you know, our light rays and that vector blur that we added. Which, you know, enhances that effect. And then that's when our projectile starts to appear. And so I got to this frame, and I was concerned that maybe the vector blur was messing up the edges there a little bit. So to check that nothing was happening that shouldn't be, I just changed the size of that mask a bit, and so it seems it's actually the fluids themselves that are creating that strange kind of pattern there. And so we can always randomize it, but I thought it was kind of interesting that, you know, it kind of looks like the head of a dragon with its mouth open there. So that's sort of the funny thing about fluids. So I tried changing the randomness of the fluids here, because I remember it's supposed to look more just like a spherical emission. And then I think we need to test this by just going through a few frames and actually seeing what is happening. And the best way to do that would be to do a preview render. So I normally check that, you know, just the first few frames are good, and then once I'm satisfied that everything's okay, then I'll actually wait a few minutes to do a half res render here. And once that's done, let's see what is going on. So I think the issue is I forgot to set the particle count back to 100 for the projectile. So we need to make sure that that is set to 100. But I'm getting some strange results with the fluids there, which I'm not completely happy with. So this is how we troubleshoot things. First, it's a case of maybe it's the emission, maybe it's the speed of the projectile there. So I actually just dragged the keyframe across so that our locator travels a bit more quickly, and then rather than coming to a complete sudden standstill, I'm actually just going to have a few frames where, you know, the emitter continues to drift past the point of impact here, just to allow the fluids to sort of resolve whatever they're going to do. And of course, when you make changes in the orthographic view, always best to work between two cameras there. So now the spell will travel faster, which means it will have slightly more particles because they're emitting from speed. And then rather than coming to a complete stop, they will continue forward a little bit more. So let's see what the result of those changes were. So there's still something that doesn't quite look right. And what I noticed is that we're getting these weird kind of squiggly lines in the fluids, and it definitely isn't how it looked before when we were setting this up. And the issue is that when we created our particles ring and we selected a new OBJ model and we selected the tube, that actually replaced the sphere. And so now our projectile layer, it simply doesn't have an OBJ, so there is no volume to allow the fluids to properly disperse. So to get that model back, you can just right click, reveal in Explorer. That'll bring up the library of OBJ models that are on your computer in Trapcode Particular. And then now what we can do is just manually set those projectile layers to use the sphere, which is what they were supposed to use before. And the ring layers are still using the particle OBJ master file, so that's fine. And if things don't update immediately, we will want to refresh the model by clicking on reload model there. And it obviously, even working with Trapcode Particular, I completely forgot about this. So no matter how experienced you are, you'll always need to know how to troubleshoot issues and just go through step by step. What is creating the issue? First, I thought it was the adjustment layer. Then I thought it was the speed of the locator. And then I realized that it was something to do with the actual OBJ files themselves. So you're always going to run into issues when you're working. And so now that we've done that, we can just render this again, and this time we'll have the original result which we were expecting to have. And so that's our dynamic simulation. And as for this project file, so you can follow along with this, tutorial. But if you want to actually have the project file, we're actually going to be giving away this Expelliarmus tutorial file that we just created on our Instagram. So all you have to do is just follow us and just send us a DM, and then we'll send you a link to that project file on Google Drives. And also, whilst you're on YouTube and watching this tutorial about Trapcode Magic, actually check out the rest of the spells that we have in the Trapcode Magic pack. So as you can see, there's a whole overview of all the different spells, seeing how much attention to detail went into just this one spell. You can imagine how much went into the others. I would also really appreciate it if you could take part in this channel opinion poll. Basically, now that we've finished Trapcode Magic, we have three kind of choices of what we can focus on next, primarily. At some point we'll do them all. At the moment, Trapcode Elements version 2 seems to be the favourite there, followed by Trapcode Super second. And if you haven't heard of Trapcode Elements, that's the Avatar-inspired elemental pack. And we also did a poll on which elements people are most interested to see iterated and improved upon, because we've got some amazing improvements that are going to come to the water as well as lots of new projects that are in a work in progress state. There's also the earth as well. The fire is a favourite, so that'll be seeing some improvements. And also we'll be going over the air projects as well, as we've learnt a lot from Trapcode Magic and we can bring that experience to Trapcode Elements. So thanks for watching this tutorial. Make sure you stay tuned for next time by subscribing to the channel so you don't miss the next tutorial. And thanks for watching.